All right, so now we're going to graph quadratics. And we're going to learn all the key functions in order to do so and the things that you need to look for on the graph of a quadratic. So first, we should already know that a quadratic function in standard form is ax squared plus bx plus c. Now when we're graphing, for graphing purposes, we're going to see it as y equals ax squared plus bx plus c, or f of x equals ax squared plus bx plus c. Now there will be times where we will go back and forth between y or f of x, but just like we learned functions months ago, they mean the same exact thing. Y is the same thing as f of x, and f of x is the same thing as y. So next, the parent function is going to look like y equals x squared. So the parent function is the simplest function in a quadratic family. So it's so simple because it's just y equals x squared, and that's it. Right? The graph of the function is a curve. So when we draw it, it's going to be a curve, and we call that curve a parabola. Now, the term parabola and quadratic are also interchangeable. So there may be times when you're doing your work, or even when I'm talking, if I say a parabola or a quadratic, they're the same thing. Okay, when we graph, the first point that we're going to want to graph on our quadratic function is the vertex. So the vertex has to be written as a coordinate, so it must be a coordinate. And we're going to find the x of our vertex by the opposite of b over 2a. The y we will find when we plug in the x that we receive. So we'll do an example of that later. The definition of a vertex is the lowest or highest point on the graph of a quadratic function. And it is also the turning point of our function. All right, so the vertex, like I said, that's the first point that we're going to want to graph. So we're going to fill out this table that we have in the middle. So to find my vertex, we're going to take the opposite of b over 2a, which when we look at our function, which is y equals x squared, I don't have a b or I don't have an a. So x is going to be the opposite of b, which is 0, over 2 times a, which is 1. Remember, there's 1 in front of that x squared. So my x is 0, because 0 divided by anything is 0. So I'm actually always going to put my vertex in this middle set of boxes here. I always want to put that in the middle. Because if you think about it, it's like the middle of your parabola, so we want to put it in the middle here. So I'm going to put my x here. That's the x of my vertex. Well, now we want to find out what the y of my vertex is. So all we're going to do is we're going to take our function again, y equals x squared, and I'm going to replace my x with the x of my vertex, which is 0. So now we have y equals, well, 0 squared is just 0, so y equals 0. So my vertex is the coordinate 0, 0. So that's the first point that we're plotting on the graph. So I'm going to make a dot at 0, 0, and that is our vertex. All right, so now we want to keep filling in our table. So if we look under the x column, well, the 2 boxes above my vertex, I'm going to pick 2 numbers that are less than 0. So I'm going to pick the next number that's less than 0, which is -1, and then the next number after that, which is -2. Going in the opposite direction, we're going to go with 2 numbers that are higher than 0. So the next number that's higher than 0 is +1, and the next number that's higher than 0 or than +1 is +2. Okay, now to find what our y value is for each of these two, we're going to plug it into our function. So our function is still y equals x squared. So we're going to replace x. First, we're going to replace x with 1 and solve for y. So y equals, well, 1 squared is 1. So when my x is 1, my y is 1. Well, now we're going to replace x with 2. So y equals, instead of x, I'm replacing it with 2. So y equals 2 squared is 4. So when my x is 2, my y is positive 4. We're also going to do the same thing when x is negative 1 and x is negative 2. So y equals, instead of x, I'm putting a negative 1. Well, negative 1 squared, negative times negative is going to give me a positive. So y, again, is positive 1. And when my x is negative 2, well, negative 2 squared is going to give me positive 4. Now, if you look at your table, well, here and here, when my x is positive 1 and my x is negative 1, my y values are both 1. Same thing with our 2's. When my x is positive 2 and negative 2, well, my y values are 4. That's what we want. Our table should always look like that. It should look symmetrical. So those are the next points we're going to plot. So my x is 1, my y is positive 1. When my x is negative 1, my y is positive 1. Then when my x is 2, my y is 4. And when my x is negative 2, my y is positive 4 again. So we should get our points that look kind of like they're in a V. But when we graph it, we're not graphing a V. We're not making this a point. We want to start up here, and we're going to bring it down. We want to curve it at the bottom and bring that curve right back up through all of these points. And then don't forget your arrows. The arrows are important because that's showing us that our function is continuously going in both directions. Now we're going to take a look at the axis of symmetry. So axis of symmetry is always, always, always written as x equals, because our axis of symmetry is going to be a line. So it's always x equals, well, it's the x of your vertex, which is just negative b over 2a. So what it does is it intersects the vertex and it divides the parabola in half. So again, because my axis of symmetry is a line, it's going to be a vertical line. We remember when we graphed lines, x equals is a vertical line. So it's going to be a vertical line that goes to the x of my vertex. Well, we already found that out, which is 0. So it's going to cut right through my vertex. And when we draw it, we're going to draw a dashed line all the way down. So now we can see that's where it's cutting my parabola in half. And one of the last things we're going to look at is whether the parabola opens up or if it opens down. Now, if we look at our graph, look at the parabola we drew, well, we can see that our parabola opens up. But we can also determine that before we even graph it. So we can see whether we graph it correctly, whether it's supposed to open up or if it's supposed to open down. So in order to determine that, we're going to look at our value of a in our function. So if we look at our value of a, if a is positive, then our parabola will open up. However, if a is negative, then our parabola opens down. Now the value of a and whether it opens up or down is also going to tell us if our parabola has a maximum or if it has a minimum. Now, if we look at this parabola here, well, it has a lowest point. So a lowest point, it's going to have a minimum. The highest point is going to be the maximum, which should make sense. So if our A is positive and it opens up, well, then we have a minimum. If A is negative and the parabola opens down, then we have a maximum.